Man, I hate golf.
Alright, Wyatt, you're not putting correctly. You gotta think about the putt.
What do you want me to do? A physics project dedicated to golf? Mostly done by ChatGPT.
Alright, to understand how to putt, you need to understand the physics behind a putt. Do you know the physics behind a putt?
No, what are the physics?
It's speed.
Once you find speed, is that all you need to make a putt?
You think that speed is all that matters? No, you gotta look at the green. You have to look at the angle of the green. You have to look at the distance. You have to look at the moisture content. You have to see how hard the green is or soft the green is. Okay, to understand the distance and like the speed you need to put on the ball, you need to look at the green. If the green is hard, dry, and the grass is cut short, then the green is hard and your ball is going to travel farther. If the green is moist and the grass is longer, then the ball is going to travel less. So looking at the green right there, what do you think that green is?
Is it dry and the grass is cut short, so the ball will travel fast?
Exactly. Alright, Wyatt, when you play, you have to make sure that your hands travel straight through the ball. In that original replay, in that original putt, your hands are traveling diagonally. Watch the replay. Did you see your hands move diagonally across the ball?
No.
Watch the replay again.
Okay, so my hands don't move diagonally, it's straight through the ball.
Correct. Now, you ready to putt now?
No, I think I should understand the physics concepts first.
Well, let's go to a classroom. Alrighty, Wyatt. The physics behind putting are simple. You just need to know some basic math and a little bit over there, and you should be good to go. Starting off, how much weight is in this golf ball?
10 kilograms?
Incorrect. Give me it back. This is ridiculous. It's 0.0459 kilograms. This is basic math. You should be able to know this. Now, from there, we know that 0.45 newtons is going to be the normal force because we take this times the force of gravity, which is about 9.81, and we get 0.45 newtons. Alrighty, so if we look at the coefficient of friction, we have the coefficient of friction equals the frictional force exerted on the golf ball over the like normal force, which is 0.45. Now, we plug this in. This number, 0.003, is an estimate. I don't know the exact, coefficient of friction for the green at San Jose. It's just an estimate. We know the normal force. We do this equation. We multiply it out. What does this number say?
0.00135 newtons.
Oh, my days are good at math. So we look at that. That is the frictional force, which is important because we're going to plug it into this equation, which is the acceleration equals the frictional force over the mass, which we get from here in kilograms. And that's going to get what number, Wyatt?
0.0294 meters per second squared.
Terrible. It's supposed to be negative. You should have known that. Alrighty, Wyatt, take a stab what this means.
So is this one the final velocity squared equals the initial velocity squared?
Yep.
Plus 2 times acceleration times distance.
Correct. The distance is going to be 5 feet, which was the putt that you missed horrendously at the beginning of the video, is going to be in meters. So you know that, and then that you get from this, and then that is the final velocity when it goes in the hole. Hopefully, is going to be 0. You do this equation, you get what number?
0.299 meters per second.
Nice. That's going to be the initial velocity. So impulse equation, we learned this. So you plug everything in. You take the original kilograms, plug that in, take that number, you plug it in there, over 0.1, which is the average amount of time the putter makes contact with the ball. And then you divide that out, and what do you get for the force of the putt that you need?
1.373 newtons.
So do you think we're done now?
No.
Absolutely not. We have another equation over there. Alrighty, Wyatt. Work and power equations. I taught you enough. You explain this one.
Alright. So work equals force times distance. And we found force in the last equation. So work equals 1.373 newtons times 1.524 meters. So for the work, you get 2.092 joules. Now for power just is work divided by time. So we just found work, but 2.092 divided by the time that the putter comes in contact with the ball, which is 0.01 seconds, and you get 209.2 watts.
All right, Wyatt. Remember what I taught you.
About 6 foot putt.
Maybe next time.